or we want to look at three important approaches that we can take in modeling complex systems and how we can make complex things easier. So the first one on the left, which is called partitioning, is, you might also know it, or it's sometimes described as divide and conquer approach, which is very common in IT. So you have a complex system, and let's assume it's an information system. So you want to create like a system where we can manage all the information around the Campus via project, for example. Let's assume you want to create one big system that can do all. It can manage our customers, it can manage our sales, in our inventory, our warehouse, our promotions, and maybe even have a front end for e-commerce where we have our online e-shop. So that's a large, big information system with a lot of different parts, and it's going to be quite complex. So that's because there are many interactions between those different parts. So when somebody buys something on our shop, it's going to affect our warehouse because we need to reduce the stock. And so there are many different interactions on many levels. Then we have a front end. We have a database. So by front end, I mean what the user is going to see. I'm going to have a shop front end. I'm going to have an administration back end where somebody from the team needs to be able to do something. We have a database, and all these components interact somehow. So what we can do is we partition the whole problem, or we divide it into smaller pieces to make it to handle it better. So in this case, we take the complex system from the slide before, and we simply make it into, or we divide it into three parts that we hope are easier to handle by themselves. So for our information system, we could say, okay, well, let's handle the database part separately from the UI part for the web shop, and separate that again from the back end where our team is going to log in and be able to add new products and stuff like that. So let's divide the whole system into different parts. So that's one very useful and important modeling approach, or model building approach in IT specifically, but not only in IT. So the second one in the middle is abstraction. So that basically means that we do not have to model the world, or we don't have to have every detail of the world in our model. So we leave out parts that are not necessary for our use case. So for example, if I wanted to have a database of customers, I decide on which properties such a customer will have in my database, knowing that this customer, of course, in his real life has much more information attached to him or her. So maybe it's not necessary to know where a person was born for my use case. So I want to sell beer to someone, why would I need to know where this person was born? I leave that out of the system, but in the real world, this person, of course, has this property, but we don't need it, we abstract from that. And we can do that with any information object, and because we are modeling information today, and we're in a module called information management, this is often one way how we abstract from the real world. We leave out the unimportant stuff, and we model only the stuff that's important to our use case. So we simply leave out stuff and abstract from it. And then, so for the house example, maybe to complete that, we have in the house example only specific features, which is where the walls are and how long they are, and where windows are, and what's the width of the windows and stuff like that. A house has, of course, many more features that we could have put in here, but it's not. It wouldn't be helping for this model. It wouldn't help us understand the layout of the house if we, for example, added the color of the walls or the color of the floor or stuff like that. We leave that out. We don't need it here. So that's also abstraction. All right, and the third one, projection, basically is what we have also seen in the house example. So we have one floor layout example, and the other one is the view from outside from different angles. That's two different projections, and the projection is simply a different view on the same object. So we create different models that have different purposes for the same object. So for example, in our information system, we could have an entity relationship model, which we'll create today, so with a different use case, but in the case study, you will create one for our information system. But that's only one kind of model how we can look at our system. We could also design a model that describes how the user interacts with the system. So for example, what are the functions that a user can run in our user interface. So what's the functionality and what happens in the background? That would be a totally different kind of model. It would describe how the user interacts with the system. And then there are other models. So for example, we could have a model about data security. So we would then only model the relevant features for who may access the system and what parts of the system, and how do we do that. So that would be a different projection on the same object on our information system. So we then end up with a set of views or different model types for the very same thing. All right, are there any questions about that? And so basically what we're going to do today is we use all three types of modeling approaches, because we are going to partition the system and basically saying, okay, we only want to look at a certain part of the information that we need to manage is already partitioning the whole system, because usually it would involve much more. So we only look at one specific part, which is basically the database. Then we use abstraction to model that information, because we don't need everything in our information model. We only need stuff that we actually need to perform our processes. And then projection basically is we only have one view, but we could add other views to our information system, modeling different aspects of the system. So are there any questions up to this point?